Welcome to the online lectures for software engineering. Today we'll begin with the topic goals, attributes, and metrics. In the previous classes, we've studied what software quality assurance is, and we've also studied the different actions or different tasks for software quality assurance. Now, why are we going to perform those tasks? Those tasks are performed so that a few goals can be achieved. Those goals are requirement quality, design quality, code quality, and quality control effectiveness. Now, what is requirement quality? Now, this within requirement quality, the software quality assurance team, they must ensure that the software team is properly reviewed and it is going to achieve a high quality software. Now, here high quality software means it should give you correct result. It should have correctness. It should be completeness, consistency. These all things should be present for the requirements. That is correctness of the requirements, completeness, and consistency. The next one is the design quality. Now, the design quality here means that whatever design that you're developing, every element within the design model, it should be assessed that it should be the high quality. Whatever you're developing, it should be the highest quality. So the software quality assurance team is going to look for each and every attribute of the design so that they should be achieving the high quality. Every element is assessed for quality. The next one is code quality. Now, code quality here means the source code. Now, the source code of whatever you're writing code for your program, this source code, it should have the coding standard, that it should meet all the coding standards. Should not be very complex. It should be simple. It should have the all the characteristics for maintaining. So you should maintain the quality of code. The next one is the quality control effectiveness. Now, within this quality control effectiveness, a software team is going to check that all the resources in such a way that each everything should be the high quality result. Each and every resource is going to be checked that it should achieve a high quality result. So here we have got the table where you have got goal, attributes, and metrics. Now, for each and every goal, that is your requirement quality, what are the different attributes? You've got ambiguity, completeness, understanding, volatility, traceability, model character, clarity. So for each of them, you have a metric. The same as for design quality, code quality, and your QC effectiveness. So there's a table that has got all the attributes and metrics written in place. Then the next one is statistical software quality assurance. Now, statistical quality assurance, it reflects all the different growing trends that are there within the industry. So the statistical quality assurance follows a few steps. The first one is information about software errors and defect is collected and characterized. That is, there are specific errors that that there is more likelihood that they are going to occur. Then you also know, when you know what error is, you will get to know how that error falls in what category and how you're going to resolve it. So software quality assurance is going to do this, categorize all the different types of errors. Then the second one is an attempt is made to trace each error and defect to its underlying cause. Now, once you have made different categories, if there's a category one is there, category two is there. After that, what you can do is that when you know what category it falls in, you're going to identify how you can resolve it, how you can trace it back to the to that specific line of code. Like there is a example, there can be a design error, or the standards are not met, so that is a standard violation is there, or there was poor communication with the customer so that you did not gather all the requirements correctly. Then the next is using the Pareto principle. Now, this Pareto principle states that 80% of the defects can be traced to 20% of all possible causes. That is, isolate the 20% in the vital few. 80% of the defects, these are traced to 20% of possible causes. That is, you do not understand what the customer has said. That is going to be your Pareto principle. Then once the vital few causes have been identified, move to correct the problem that have caused the errors and defects. You've categorized all errors. First step, you've categorized all errors. You've identified what is the cause. You've identified if there's any poor communication using the Pareto principle. Then you're going to correct all these errors. And the next topic is software reliability. Now, what is reliability? Reliability is a measurable system attribute. So non-functional reliability requirements may be applied quantitatively. Now, this is going to define the number of failures that are acceptable during the normal use of the system. That is your reliability. Now, what is functional reliability? Functional reliability means requirement that define system and software functions that avoid, detect, or tolerate faults in the software and so ensure that these faults do not lead to system failure. Now, reliability means there is an error and system can accept that amount of error, that number of error is acceptable. Whereas in functional reliability, it happens that you get to know that there is a specific error, you're going to try to avoid it, and you're going to ensure that this specific error, it is not going to cause some system failure, that is the entire system crash. You're going to avoid the system crash. Error should not cause the system to crash, that is a system failure. So that is software reliability. Now, within software reliability, of the software reliability and availability. In software reliability, the probability of failure free operation of a computer program in a specified environment for a specified time. Now, what is the within software? Now, here we have seen what is reliability and what is functional reliability. Now, software reliability means that what is the probability that there is going to be no error or no failure within the system when you're executing a specific program at a specific time. That is your software reliability. No error in a specified time. Then the next is availability. Availability is the probability that a system at a point in time will be operational and able to deliver the requested service. Available means the specific operations and features, these are available to the customer. Now, if we take an example of this ATM, if we take an example, sorry, for a bank. Now, the bank is going to function for up to 3 p.m. or to 4 p.m., right? but still you can make transactions using the ATM. That is, the services of the bank are available by the ATM. You can be able to withdraw cash or make online payments by making use of the given customer ID. Online banking systems you can use. So that is availability. Those specific features are available at any time, as ATMs are fully functional for 24 hours. So this is software reliability. Now the reliability specification process, it has got a few categories. That are the risk identification. Risk identification means you're going to identify why the system has specifically crashed. Risk analysis, you're going to identify how much it is going to cost you when the system crashes. Risk decomposition means you're going to identify what is the main cause that caused the system to fail in the first place. Then risk reduction means when you know what is the cause that the system is failing, you're going to identify and you're going to try and avoid those type of errors. That is, generate reliability specifications and define acceptability levels of failure. That is, if suppose a specific file is not being executed, how much is your level of acceptance? So that's your reliability specification process.